Hey guys, welcome back to Cheenta Statistics Department live class, problem solving class on Thursday. It happens, it's like 8th day, I guess, the 7th or 8th problem solving class. So we are doing this from the past 8 weeks. So this is super exciting and consistent, and I will be doing this for the next till like Cheenta Statistics Department is alive for the people out there, for the statistics people out there, and data science people out there. Okay. So let's get started, guys. Let's get started. So what is on my mind today? Yeah, so my whole thing is technology is working super smooth. So let's do something really exciting. So I have planned today. Hi Satvik, I have planned today to do something exciting about the connection between probability theory and real analysis. So any guesses on how the connection is? What is the connection between probability theory and real analysis? Any guesses, guys? Any guesses? Any guesses how probability theory and real analysis are connected to each other? What do you think? Satvik, in the live and here people. You can unmute yourself and tell me. Any ideas how real analysis and linear probability theory are connected to each other? Go ahead. So can you tell me like one idea of real analysis where, like, can you tell me an axiom? Okay, I think we have not done this axiom. We'll be doing soon. What is the axiom that connects probability theory and real analysis? Something related to convergence, you're right. Something related to convergence. Yes, exactly. So, but what convergence? So I will start with this simple problem that a student of mine was asking me in the gold course. It's a doubt clearing course, and yep. So the question is this: that xn plus 1, xn plus 1 is equal to root over 6 plus xn. Okay. Of course, xn must be greater than or equal to 6 minus 6. So let's say xn is greater than 0. So the question was, will this converge or not? Will this converge? If yes, then where? Converge or not? So this was the question, guys. Will this thing converge or not? This was the question. So any ideas how to do this problem, guys? Yeah, like any ideas of how to do this? You will use the monotone. Who was this? Yeah. So Tanvi is giving an idea that we will be using monotone convergence theorem. So let me revise what is monotone convergence theorem. Monotone convergence theorem, it tells the following. Very simple, very intuitive aspect is this. Let's say you have a ceiling up here and you're going up and up and up and up and up. Somewhere you will hit the ceiling, right? Or maybe below, right? That is either the monotone convergence theorem. Okay, or if you are coming down, 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 there will be somewhere you will hit, right? That means mathematically, what is the idea? Mathematically, it means that if you have a sequence which is increasing, let's say sequence is upper bounded, then this too implies that xn converges to some limit. The limit must exist. Okay, guys, the limit must exist. So this is the basic. Hi, Tarun Sonapati. The limit must exist, guys. This is the basic idea of monotone convergence theorem. Or similarly, if xn is decreasing and if xn is greater than or equal to some x, then the limit must exist. So it means that if the together, if I write it in a together format, it means that if xn is monotone, this or this, and if xn is bounded, this implies together that xn to like somewhere it's going towards the limit. It's very intuitive. I just explained why it's intuitive. This is what monotone convergence theorem is. So Tanvi is asking me that, giving me the idea rather, that to prove that xn is increasing, xn plus 1 is increasing. Okay, and bounded above. Do you think it's bounded above? Do you think it's bounded above? So I'm going to show you something exciting today. It's called fixed point iteration. Okay. Maybe you've learned this. Maybe you've learned this. In the meantime, you think about this. Maybe you've learned this in your boring numerical analysis classes. Okay. But I will show you the beauty of this. Okay. And how probability and linear and real analysis are connected to each other. Okay. So maybe I've used this fixed point iteration theorem to prove the existence of Newton-Raphson convergence of whatever the sequence is and stuff like that. But here we'll understand the convergence of that. What we'll understand is the following today. So we of course have this tool to prove it, but to understand the beauty of this, we'll understand the following. Now let's say instead of this, we have this f of xn plus 1 is actually equal to some f of xn. Okay, it can be anything. F of x here is equal to root 2 plus 6x. In some other, it's a general case, right? Fx can be x plus 1 by x. Okay, a lot of different cases. Let me just open the homework problem we have made for the crash course of the first and second years, not the crash course. Sorry, the free 1 month course for the first and second year all over the country is the following. I will just share the screenshot of it. You will understand how they're related. Snipping tool, kaha gaya? Ha, aa gaya. So, these are the questions that we have made. I will just paste it over here. Okay, you can see this. You can understand from this here. Okay, many such problems are not given over here. I wanted to give a different side. Anyways, the idea is that there can be a lot of such functions, okay? Such functions, many such functions. Okay. So my question is that for which fx, xn plus 1 will converge? That is a very generic question, right? For which fx, like f of x, xn plus n will converge, right? So it depends on two aspects. One, where the first value is, where x1 is, and the second, the f. Upon these two things, these two ideas actually rely upon. Okay, what is the first starting point? Okay, if you have heard the famous butterfly effect, okay, in chaos, I don't know if you have seen the film of Oxford Murders or not, but here that is the idea, like a single initial change in the change in the initial value can do a lot of difference. Okay. Changing the initial value can do a lot of difference. So let's check it out. Let's check the geometry of it. Okay, let's check how it happens in real life. I will show you some animations over here, guys. Just give me a minute. I will show you some animations in the meantime. Let me just search it. Yes, I have got it for you. Let me just check. Yeah. Okay, this is what I mean. So I'm just sharing the screen with you now. That what is meant by. Okay, I will just yes. I will just share the entire screen. That will be better. Here also I will share the entire screen now to help you understand that. Okay, so this is the idea, guys. So if can you see my screen? Can you see the screen, guys? Fixed point iteration ka screen. Yeah, can you see the screen, guys? Fixed point iteration ka. So what does it mean, guys? I will just zoom in. So what does it mean? Understand this. So this is a function. C ko chhod do. Understand this. That what does it mean to? What does it mean that this function is converging somewhere? Okay, like f of x. This is the fx. Okay, this is the gx. So xn is starting. Let's say this is a starting point. Okay, this is a starting point, and then is the next point. Okay, so understand this is xn, x1. Say this is x1, and then what happens is that f of x1 is this, right? F of x1 is this. That is the x2 over here. Okay. Now as this is the y is equal to x line, the red line is the y is equal to x line. So if this is x2, then this is x2 ka like correspond this. What is this point? This is x1 comma f of x1. This is x1 comma f of x1, right? That is x1 comma x2. This becomes x2 comma x2, right? This is x1 comma this is x1. This goes to f of x1, that is x2. This becomes f of x2, right? F of x1, that is like x2 comma x2. Here, what is this therefore? This is actually x2 comma f of x2, right? That is x2 comma x3, and then this is x3 comma x3, and then this is x4 comma x3 comma x4. Then again, this is, you can see this is x3 comma x3, and then x4 comma x4, and then you can zoom in and zoom in and zoom in. What has happened, you can see over here. Okay, so what is happening? This is actually converging. This sequence is actually converging to the meeting point of this f of x and x. Okay, this sequence is actually converging to the meeting point of f of x and y is equal to x line, right? Did you understand, guys? This is a very important aspect, guys. Did you understand? Did you understand, guys? This is a super important aspect. This is super important, guys. Okay, I hope all the people on live understood this, guys. Let's see now. Let's understand now how what is the mathematics behind it. We will understand the mathematics behind it now. Okay, what is the mathematics behind this behavior? Okay, what is the mathematics behind this behavior? You will understand it now. Let me take a picture of this so that people can understand. So I will sort of paste over here. So what is exactly happening, guys? It's happening like this. So this is the x1, guys. This is the x1. This is x1, and it's starting from here. This is x1 comma x2. This is x2 comma x2 because y is equal to x line, and this is x2 comma x3. Okay, because it's sort of the base, the x is equal to x2 here, and the height is f of x2, that is x3. And this continues, and you can see, and you have shown that this is converging at this point. Let's understand why it's converging. Let's assume fx is continuous, guys. This is called the fixed point iteration. Okay, let's say fx is continuous, guys. So what is happening? If you define f of x plus this is equal to f of xn, now if you take limit n tends to infinity, do you know the result? That this will be this, and if you take limit n tends to infinity, since f is continuous, then what will happen? Since f is continuous, there is a result that f will the limit will go inside. Okay, and it's actually equal to, since you must write like this in the ISI MStat paper, PS paper. Since why? Because f is continuous. Now what happens is the following. What this turns out to be, exactly this turns out to be what you do actually. This limit is L. If you know the limit exists is L. So L is equal to, this is what? F of L. So L is equal to f of L. So what is exactly happening? We are actually equating f of x is equal to x. That means if a solution exists, if f is continuous and if a solution exists, it must be the intersection point of y is equal to x line and y is equal to f of x. So this is the beauty of this, guys, and this is exactly what the entire thing shows. So if you learn these guys in your higher classes, yeah, this is related to Newton's method. You're right, but we use this to prove Newton's method, Srinivas. Okay, so what we exactly do is the following, that we try to understand the geometry of it. Okay, we try to understand how this whole thing is related to each other. So this is called dynamical systems. Okay, so what is, there's a beautiful idea, like it's changing over time. Okay, and you understand that this, in this case, it is very easy. Okay, But in some other cases, let's say we are starting from here. Let's say let me draw a different, let me take a different starting point. Let's say I am taking a starting point of 0 point, let's say 1. Okay, let's take that. Oh, 1 is not happening over here. Let's say 2. Okay, okay, 2 is not a good idea. I will show you why. 2 is not coming out to be a very good idea. Okay, 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 2 is not coming out a very good idea. I will show you why in the same one. So in the same diagram, if you draw the diagram, guys, I will show you. If you draw the diagram, guys, like this, it was like this. How was the diagram? Just give me a minute. I will just copy paste it. Yeah. You see the diagram, guys, over here. This is the diagram of 2. It's starting from 2 now. It's going hitting here, and similarly it goes to the y is equal to x, and then it's going down. You see, therefore the gap between it increases, and therefore it will never converge. So if you see the output of this, guys, I will show the output of this. This will become, this has, the sequence has become minus infinity over here. The sequence has become minus infinity over here. It's going to minus infinity actually, step by step. So therefore it always doesn't converge. Okay, doesn't always converge. So for which condition? Therefore it depends on initial value. That's what I wanted to mention. Not only depend on the fx is equal to x, but also the initial value. Not only the fx, but also the initial value. That's what I wanted to make you understand. So therefore we will do a theorem that you always do in your numerical analysis classes. That we will give a condition on which, on f and x naught, the initial x1, such that xn plus 1 is equal to f of xn converges. This is really super important, guys. Okay, and this will enhance your understanding of the entire result of entire understanding of the real analysis part. Okay, so let's try to understand this. Let's try to understand this. Okay, if you want to play around with this, I will show you a certain thing. I will give you a link, but let's try to understand this. Let's try to understand this. Okay, I will share with you theorem now. Theorem goes as following. This is the following theorem. I will show you the meaning of the theorem. I will prove the meaning of the theorem, the result of the theorem in front of you. This is a theorem that you do in numerical analysis classes, okay, to prove the convergence of Newton's method. So what do you have over here? You have that theorem. It tells that if g is a function, differentiable function from this, such that g dash of x is actually less than 1. This is the main idea. Less than equal to alpha less than 1. We will show the importance of this. But what does it mean? It means that the rate of change is actually not changing of gx too fast. Okay. The rate of change of gx is not too fast. And if the sequence, if g has only one fixed point in a comma b, and the starting point must be between here. Starting point must be here. X naught must be over here. Okay, between a comma b. Then only it will converge to L naught. Then only it will converge to L naught. The fixed point. What is a fixed point? A fixed point means fx is equal to x. That is, fx is not changing. Okay, that point where fx is not changing. Like x is not changing. Like when f is applied over x, then x is not changing. That fx is equal to x. This is the meaning, and that's what we have got. Now this is the condition for the limit to exist, right? If the limit exists, this must be equal to this. So it tells you the following. That means if you have an upper bound on the rate of change of gx, the fx here actually, the initial fx, then it will not, this sequence will converge, okay, to the fixed point, exactly that fixed point, okay. Let's try to prove it now. It's very easy proof, guys. It's just basic understanding of mean value theorem, okay. So what is the idea? What we need to show? We need to show the following, that xn, as I have told you, the best way to show that a limit sequence is convergent to a limit L is to show that it's bounded by something epsilon n which goes to this. This will show by Sandry's theorem. Why Sandry's theorem? Because this implies that xn is less than L plus epsilon and greater than L minus epsilon. So by Sandry's theorem, this will go to L, this will go to L. As n tends to infinity, so this will also go to L. So therefore, the main method of showing that the limit is xn is convergent is this. This is a super important, interesting method, okay? Super useful method actually. So you use this, guys. You want to show this. So here you want to show that xn minus L, where f of L is equal to L, okay, is less than some epsilon where epsilon is goes to 0, okay. So what is the first step you must do as n tends to infinity? What is the information you have on this, guys? That you have L equal to FL and you have xn is equal to f of xn minus 1. So what you do, you just replaced it by, this implies that you replace it by, so why you want to do this, guys? Why you want to do this? Because you want to induce the information on f into the equation to prove, right? That's why you're doing this, guys. Minus f of L is less than epsilon, we have to prove it. So we have to bound this. Now, do you know any good bound on bound this? How to bound the difference of fa minus fb? Do you know how to, there's any result on how to approximate fa minus fb? Do you know any result, guys? Do you know any result, guys? How to approximate fa minus fb? Do you know fa minus fb? Have you ever seen fa minus fb somewhere, guys? I'm sure you must have seen from your 11, 12. Go ahead, guys. Any ideas? Yeah, Bolo, Sneha. Where did you see fa minus fb? In your 11, 12, first year, second year? Where you have seen fa minus fb? LMVT, right? Mean value theorem. Lovely. Good. Super. You have seen it in mean value theorem, guys. So what do you do? Therefore, and also you have miraculously you have the information of fx. Actually, this is the idea. This is not miracle, okay? They wanted to prove this. That's why they put an information on f of dash of x so that they can prove it easily, okay? So the proofs, everything, the theorems all go backwards, okay, and they never go forwards, okay? Unless the extremely, like most of the proofs, the conditions of the proof, you see, they all go backwards. The proof all go backwards, okay? Mathematicians and these proofs are really, those who make the proof are really lazy. So you just do that, guys, and also you have a bound on this, okay? You will understand why less than 1 is required. So how did they approach backwards? They was first wanted to approximate this by this, so that is approximate by f dash of what? F dash of xi n, where xi n is xi n minus 1, where xi n minus 1 is actually between L and xn, like the minimum of L and minimum of xn, the difference between that. Let's say L is greater than xn. I'm just assuming, okay? This is a very bad condition. This will be the idea. For some xi, okay, between the maximum of xn minus 1 comma L and minimum of xn minus 1 comma L. This, between this two, it will be there. Into what? Into modulus of xn minus L, right? This is what you have got, right? Again, this is actually equal to what? This is actually equal to f dash of xi of n minus 1 into f of xn minus 2 minus f of L. So you can again apply what? F dash of xi n minus 1 into f dash of xi n minus 2 into again that. So it will continue like this, guys. It will continue like this. Okay, and it will go to what? You will get the final result that if this, We'll continue to the last point. Understand that we can now use the condition. Okay, this is the modulus. Okay, I missed the modulus. I'm so sorry. There's a modulus sign over here. The final thing is that f dash of x is less than equal to epsilon, alpha. So all of them must be less than equal to alpha, and each will go down to every single time. So there will be two of them. Just give me a minute. Yeah, into n minus 1 into x1. I think n minus 2 into x1 minus l. This will be the final result. But x1 is a starting point, guys. If you go on, like, all of them, modulus of all of them will be less than equal to f alpha. Alpha n times will be n minus 2 times will be there, and into the last term x1 minus l. Okay. Did you understand this step, guys? This calculation, I did a small step jump. Did you understand this, guys? Did you understand this step jump? A small step jump I did. All of you understood? The 2022 people mainly. Did you understand this? Tanvi, did you understand? Priyansh, Sriteja. Good. Please, please. Okay, lovely. Did you understand? All the people in the live understood it? Okay. So therefore, we have the following, that modulus of xn, that is xn minus L, is less than equal to actually alpha to the power n minus 2 or n minus 1. If you just check, n minus 2, I guess, into x1 minus L. Right? Now alpha is therefore, if when we this is the epsilon n, right? Now when we can make this go to 0? Only when alpha is less than 1. Otherwise you cannot make it. Okay, only when alpha is less than 1. Okay, and therefore we put a condition on this so that it converges to 0, and therefore xn converges to L. Okay, this is a basic proof, guys. And all of you, you have done this small shortcut, no? Sure, which part you want me to repeat?
After you have written a modulus f of xn plus 1 minus f of xn. F of L, sorry.
This one.
After this, my connection.
How do I know when your connection was lost?
Yeah, here, from your beginning part.
The entire part, no? Okay, sure. Give me a minute, I will explain it entirely over here again. So we are trying to modulus. So did you understand we are trying to do this? We are trying to bound xn minus L less than epsilon n, where epsilon n is going to 0. So what we're doing is that we want to induce the information of f. So what we do is that we replace each of them by their corresponding f ka value. F of L equal to L, because we are showing it's going to the fixed point, minus f of L. Why we did this? Because we want to induce the information that f dash of x is less than equal to alpha. Okay. So what is, when we do this, you can induce that this is actually f dash of xi n by mean value theorem into modulus of xn minus, xn minus 1 minus L. Okay. Now this is actually less than equal to alpha, because modulus of this is less than equal to alpha, because that is given over here, into xn minus L, right? So similarly, you can again apply the same technique over here to get alpha less than equal to alpha square into xn minus 2 into L, and you can continue this to get less than equal to alpha to the power n minus 2 into x1 minus L. I think n minus, is it correct? I'm not sure. Just give me a moment. It will be n minus 1. Did you understand it, guys? Sneha, did you understand? Yes or no? Okay. So we have got that xn. Now understand, we have got this result now. Xn minus L is this. Now what they did is backward, that they wanted this to go to 0. So what they did, they wanted to go this epsilon go to 0, and it can only happen if and only if modulus of alpha is less than 1. And that's why they put a condition that modulus of alpha must be less than 1. That's the basic idea, okay? That's why they put a condition on this, and it goes to the limiting point. So I'm mostly concerned with the second year people, like the 2022 batch. Did you understand the 2022 batch, guys? All of you understood it? Because many of you didn't do the Polomi, Priyansh, Suryangsi, Tanvi, Srinivas, are you here? Do you understand this, guys? Good, good, perfect. Okay, lovely. So let's move ahead to. Okay, so this is a basic idea of the proof. Now let's try to apply this to this. I don't know if it works or not. If you apply this to this, then f dash of x kya aa raha hai? Is half into. Is it coming out to be this, guys? Is it coming out to be this? Can you please check? Yep. What is f dash of x in this case, guys? Yeah. Any ideas? Or have you forgotten differentiation? Yes. Where are others? The 2022 people, why you're not replying, guys? I'm repeating so many times for you guys only because you are the junior batch over here. Is it coming out, all of you? The 2022 people? Follow me? Vishal, Srinivas, please reply, guys. It's very important, guys, to reply. Okay, perfect. So this is coming out to be f dash of x. Okay, so let's check it, guys. So we have xn is greater than 0. So f dash of x is therefore is what? So understand f of x is therefore we have to understand this, where we should define f of x. Because it should be defined on a comma b, closed interval. So you can define it on 0 comma 0 comma what 0 comma so maybe upper bound, like so you will find out the limit over here. So you find f of x is equal to x. If you find f of x equal to x, I think x will turn out to be x square is equal to 6 plus x. So it will be 3 or minus 2 or something like this. 3 minus 2 9, yeah, 3 or minus 2 this will turn out. Okay, so therefore you take it 3, so let's take it as 4 between f of x to whatever the output is. It's a continuous function, so image of a closed bound interval will be a closed bounded interval, some a comma b, I don't know, but it will be some a comma b. And understand f dash of x kya hoga, therefore f dash of x is therefore 1 by 2 root over 6 plus x, and this will be maximum at, this is a minimum, sorry, so this is a minimum at, so therefore it's bounded by, let's say, so it's greater than equal to, actually this is greater than when and less than when it's 0, right? So it's bounded by, the maximum will be when x is equal to 0. So it's bounded by 1 by 2 roots 6, that is less than 1, of course, and therefore this will converge to, fx will converge to what? Fx will converge to the point where 3, right, guys? Did you understand the application of it, guys, in this problem? Did you understand the application, guys, in this problem? Boom. Yep. Okay, yeah, the new people out here who don't know, if you like something out, guys, you have to write a boom in the comments, okay? That's the.
Can you repeat the last statement?
Sure. So we have to find out we have to bound the f dash of x, right? So f dash of x, the maximum value will be taken when x is equal to 0 because it's a decreasing function. yeah, right? The decreasing function maximum value will be taken when x equals 0, right? Which is equal to 1 by 2 root 6, so it's less than 1. This is actually.
Okay.
Did you understand now?
Yes.
Good, lovely. So 202 people understood. 2022 people mainly. 20121 people are really intelligent, like they are senior. They will of course understand. All the junior people understood here who are giving the exam next year. Suryangsi, you're over here.
We are considering 1 by 2 root 6 as alpha for the assignment here.
Yeah. You're right.
Okay.
Did you understand, Suryangsi?
Yeah.
Okay. Tanvi, I hope you understood.
Yeah, I did.
Okay, lovely. So now, let's do something interesting. So this is the relationship with, this is the idea of how to show the convergence. Now I will show you where this comes up in probability theory. Okay, I will show you where this comes up in probability theory. So since it's a probability 2 going on in our 2022 batch, where we have just started random variable, discrete random variables we are doing, and on a, like next week also on, like, we will do the discrete random variables in interesting way. But let's check it out, guys. What you have done the 2022 batch on Monday? Guys, what you have done on Monday? Can you tell me? Yeah. What have you done on Monday with Utturan sir?
We did the mountain hall process.
You did the.
Mountain hall problem.
Okay, the Monte Hall problem. Okay, lovely. So he has not done any discrete random variables. So okay, let's check it out. Let's then last time I have discussed, I'm here to discuss moments in full details about the geometry behind the moments, the squareness curvature and stuff like that. But we have defined what is a discrete random variable. Okay, it's a function from a sample space 2 which is taking values x1 x2, the discrete values, okay, in countable set. And we have defined something called moments, that is expectation of x to the power k. We have defined that, okay, that is summation of pi, okay, the values of xi to the power k. This is how we have defined, right guys? So now we'll define something called probability generating function of a discrete random variable. What is that? It sort of generates a probability, okay? So it's defined as this, that it's summation of pk x to the power k from 0 to infinity. So it's for the, like, this is the definition, okay, where p1 p2 dot p1, let's say, yeah, let's do it for p1, where p1 p2 dot pk, this thing are the probabilities, okay. So understand, there is nothing related to the xi. The values of xi are not important. The only probability is important. Okay, that's why it's called probability generating function. Okay, there's something, if you have done generating function in your combinatorics class, or if you know about generating function, you will see that this is a relationship with the generating function. Okay, so it's actually so we see this when we're interested in understanding the sequence of pk. Okay, we're interested in understanding the sequence of pk, guys. Okay, this is the basic idea. So there's nothing to do with this xi, but here it gives an actual pk, so we give defined as the pk over here. It's nothing to do with the random variable values, okay. It's only to do with the, we have to only to do with the pi values, okay. It's a sequence of the probabilities. Okay, so this is a basic idea, guys. Okay, so this is basic definition of probability generating function. So you must be asking why the, like, why is important, guys? Okay, that's a very important question. Why this is important? So I will tell you. Let's do this. So I hope in the first problem solving class, guys, in the first problem solving class, I have done something interesting, where in the first problem solving class I've done something interesting. I have called branching processes. Okay, what is the branching processes? What is a branching process? It's very simple. Initially it starts with a one value. Okay, and what happens is that next step it has, so I'm doing it this value, let's say P1, P1, P0, P1, P2. That is, Pi is the probability, P0 is the probability of zero reproductions, zero birth. P1 is the probability of one birth. And P2 is the probability of two births. Let's say the family tree, okay? It's a family tree of the starting of the human race of one person. Let's say a person wants to know, a man or a woman wants to know that how many generations in the future the name there. Let's say a woman's surname is usually carried in the whole, like suppose there is a marriage, so the woman's surname is carried to the next generation person, okay, next generation child. So the child ka surname, the woman's surname is retaining for how many generations? Will it become extinct? It depends upon the reproduction rate of the person, of the woman, right? So this is the idea what that woman is trying to understand, that person is trying to understand, that person is trying to calculate. Okay, so how the surname is going to last. So this is a branching process, and usually people doesn't give birth to more than two people in the recent era. Okay, so that's why I'm just modeling it by P0 with zero probability of zero birth, P1 with one birth, and P2 with the probability of the two births. Okay, this is how it's happening. So understand that xi, so xi is the, so initially x1 is equal to x0 when initially there is only one person. Xi is the number of, xi is the size of the nth generation. That is it's a random variable. Okay, xi is the size of the nth generation. You can understand, as I've taught you like conditional probability with much more details, guys. As I've taught you conditional probability with much more details, you must understand that xi is dependent upon x0. Okay, the xi is dependent upon x0. It's very important. The xi is dependent upon x0. Okay. So the xi is dependent on x0, and each of them are varying in the same manner. What is the varying in the same manner? Each of them has, this is the discrete random variable they are following. Like x is taking value, so this is the probability x is equal to 0 is equal to p0, probability x is equal to 1 is equal to p1, and probability x is equal to 2 is equal to p2. So you can understand each of the individual there which gives, like takes birth, are behaving with this same random variable as x, each of the individuals. Okay, each of the individuals, and xi is the nth generation ka size. So what is the idea? What we are trying to do? We're trying to find the probability of extinction. Pn is the probability of extinction. Okay, and this corresponding x ka random, the way each individual is varying, or you can call it z actually, otherwise this x will get confused. This z is the individual behavior of the births. This is the z number of births of each individual. Like the z is the birth to the next generation. So its z is actually, it has a, give me a minute. Yeah, it has a probability generating function. It's a discrete random variable. It's a probability generating function g of z, say, which is what here, understand this very carefully. It's p0 plus p1x plus p2x squared. There is no pre-3, so all the probability after that is 0. So this is the probability generating function for this. So let me explain it to you again from the beginning. What is the structure of the whole thing? The structure is the following. There is a person who is starting out, or maybe bacteria. Okay, x0 is equal to 1, and it's giving reproducing either 2 childs or 1 child or 0 child. And next again, Each person are distributed in the same manner: 2 child, 1 child, or 0 child. Okay, like this. So definition xi is the number of, is the size, number of element, number of, okay, size of the of the ith generation. And each individual is taking birth, is following z, the birth random variable. The question that we are answering is the following, that if Pn is the probability of extinction, this is what we're trying to find. The probability of extinction, where this is going as n tends to infinity. This is what we're finding. And you can understand here the sequence and the real answer, and this will come up. And now I'll show you how the previous result will be coming up very naturally. That we will show you something interesting. Okay, this z has a as a probability generating function g of z, which you have seen that it's actually equal to p0 plus p1z plus p2z square. Okay, any difficulty in understanding whatever we have done till this point of time, the definition of the whole thing? In understanding the definition, any difficulty in understanding the definition, how this is building up, guys? Any difficulty? Please go ahead. Clear everything? Clear? The 2022 people, the 2021 people. Yeah, Tanvi, Suryangsi, is everything clear? Yeah. Okay, perfect. So let's move ahead to the understanding now that how this P are related to each other. Okay. Let's understand this. So what is the xn? Pn is actually what? Pn is probability of extinction at nth generation. Okay, that means xn is equal to 0. Pn is probability extinction, that is extinction at nth generation. Right? Very simple. That's probability xn is equal to 0 at the nth generation. Right? Did you get this, guys? Now, what is Pn plus 1? Pn plus 1 is actually equal to probability extension by the nth generation. This, right? Right, guys? What is this? How can this happen, guys? Tell me. Can you connect this Pn to Pn, Pn plus 1 to Pn by conditional probability? Think about this. Pn plus 1 to Pn. By conditional probability, guys. Somehow. Think about this, guys. Can you convert Pn plus 1 to Pn? Tell me how you can do it. So we are trying to understand that Pn plus 1 is the Pn plus 1 is the probability of probability xn plus 1 is equal to 0. Now Pn is the probability xn is equal to 0. It's xn by that. Now my question is that can you relate Pn plus 1 to Pn using conditional probability? Using conditional probability. Tell me. It's very easy, guys. Think about it. Can you convert Pn plus 1 to Pn somehow? Can you show the following? So what is this? As Hemant, the solution you used? So it can be 0 given xn is equal to 1 into xn is equal to 0 given probability xn is equal to 0. Right? I have drawn the conditional probability tree diagram as I always do. Plus probability xn plus 1 is equal to 0 given xn is equal to 1 into probability xn is equal to 1 plus probability xn plus 1 is equal to 0 given xn is equal to 2 into probability xn is equal to 2. What is this coming out, guys? Can anyone tell me? Let's calculate it. So probability xn is equal to 0 is what? Pn. Right? What is this? What is this? Probability xn plus 1 is equal to 0 given xn is equal to 0. Can you tell me what is the idea? What can we do next? Let's call this probability xn, okay? It will be other confusing rather. Let's not, yeah. This xn is not same as this xn. This is the probability small xn. So this is the reason you need to define the random with the corresponding names, the new variables very easily, very cautiously. I mean, yeah. Tell me, how do you do this now? How do you apply law of probable probability over here? Yeah. Probability xn plus 1 is equal to 0 means it's extended by n plus 1th generation. ठीक है? So what can happen? Think about it. Think about it. It's not very hard. Maybe it's not like this. I've given the final answer here. Yeah, bolo.
Probability that xn plus 1 equal to 0, given that xn equal to 0, that will be 1 now. Because if
That will
the
be 1,
nth,
okay? That will be 1 into probability xn is equal to 0. So you know this. But here, see, if xn is equal to 1, you don't know that probability. So you have to do entirely in terms of xn is equal to 0. That will be 1. Okay. What if xn is equal to 1? What if xn is equal to 1?
xn square, small xn square,
Why?
small xn, small
Bolo,
xn.
you're telling
Because
probability
we
xn is equal
want,
to 1 is?
no, I'm not telling that. I was saying that probability xn plus 1 equal to 0 given that xn equal to 1.
Oh, okay, okay. Probability xn plus 1 is equal to 0 given xn is equal to 1. This is?
This should be xn only
Why?
because it- because we want only we if we want that generation to extend then that.
This is just p0, right?
Hmm.
There's only one person and that person must die out. This is p0,
Hmm.
right? So how do you do this? Bolo. It's not very hard. You should be doing this, guys. You have learned a lot of conditional probability.
Will you repeat the entire thing again once? The entire question.
Sure. So initially a person is starting from here. That person is reproducing like Z. Okay. 0 with probability P0, 1 with probability P1, 2 with probability P2. An individual of them are reproducing like Z. Like Z. Okay, it's going reproducing. So we're trying to find the xn is equal to probability that by the nth generation xn is equal to 0. That is probability xn is equal to 0. We're trying to find it. And we have xn plus 1 therefore is equal to probability xn plus 1 is equal to 0. My question is that represent probability in term xn plus 1 in terms of xn. Okay. Just tell me this thing, guys. How can you write xn plus 1 in terms of xn in random variable? It's very easy. What is xn, guys? Can you tell me what is xn? Xn is the size of each of the random variables, the number of random variables in the nth generation. That is xn. Let's say 5 or 6, right? This is xn, right, guys? And the next generation they reproduce. Each of them may be reproducing to give what? To give xn plus 1. So how is this happening? Let's say there are 5 people out there, 5 people in xn. See, in each of them is behaving like z, and some of the random variable is xn plus 1. So what is xn plus 1 mathematically? This is a step I wanted to make you understand because I have short time. I will not. I'm just saying it to you. It's actually z1 plus z2 plus zn zxn. Xn is the number of number of people in the nth generation. Each of them are behaving in the z fashion. Okay, so therefore xn is the z1 plus z2 plus z. This is the main importance that I was showing you. Now the rest is very easy, guys. The rest is really easy. This is the xn plus 1 definition, guys. All of you understood this definition? Do you understand the definition, guys? Do you understand the definition? All of you? Suryanshi, Tanvi, Sneha, Srinivas, Priyansh, Polami, Bhushan, Tejash. Right? This was the main point I wanted to make you understand. Now think about it. Now probability xn plus 1 is equal to 0 and probability xn is equal to 0. How can you connect it? Bolo. I have given you the entire information. There are xn variables in the pre-nth step. So xn plus 1 is equal to this. So you can understand that xn plus 1 given xn is equal to 0 is actually nothing, is 0. Xn plus 1 given xn is equal to 1 is actually z1. And xn plus 1 given xn is equal to all the IID actually 2 is equal to z2. In fact, here I wrote it wrong. It can be more than like xn can be more than n. So what is that? How we can now do it? How we can now do it? Z1 plus z2 it will be. So how you can manage this now? Bolo. Think about this problem, guys. So what I will show, the result is the following, guys. I will show you, I will tell you the result. The result is the following. Xn plus 1 is actually equal to g of xn, where g is the probability generating function of z. That means here xn plus 1 will be equal to p naught plus p1 xn plus p1 xn square. You can understand exactly what is this was our initial goal. Exactly this type of equations we were trying to decipher from the beginning. Using this, you can actually prove that. Let's do f dash of g dash of x now. G of x is what? P naught plus g of x is what now? P naught plus p1x plus p2x square. So g dash of x will be p naught, so not p1 plus twice p naught, which is equal to now p1 plus p naught plus p1 is equal to 1. Okay, so it's equal to 1 plus p2 minus p1 p naught, because p naught plus p1 plus p2 is equal to 1. So what is happening? So g dash of x is only less than equal to 1 if and only if, like, if and only what? P naught is greater than P2. What does it mean? Logically, that then if g dash is less than 1, it means what? Xn plus 1 will converge to some L less than 1. That means it will, sorry. Give me a minute. You see, g of x is equal to x, that is g of 1 is what? G of 1 is actually sum of all these values, so g of 1 is actually equal to 1. So it's a fixed point value over here. There can be other fixed point values also. In fact, you can prove that if this is a basic idea. Xn, you will learn this in stochastic processing in your courses. The idea is that Xn, the probability of extinction, will go to 1 as the number of generations increase and increase. Finally, if and only if understand, if P0 is greater than P2, that means what? That means the probability of giving more birth, probability of giving 0 birth is more than probability of giving 2 births. It makes total sense, right? So therefore, we are getting that if the probability of giving 0 births is more than probability of giving 2 births, this xn is convergent to 1. That is, the probability extension is going towards 1. That means it will almost surely happen. This is what it means. But I am still waiting for your ideas to decipher the meaning of this. Bolo. Meaning of this. But did you understand the idea? How we can use this idea to prove this connection of probability theory and real analysis together? Okay. Did you understand this, guys? But yeah, our conditional probability problem is still left. That is really not hard. I will show it to you. That's really not at all hard. I will show it to you. But did you understand the ideas, guys? Yep. Suryanshi Tanvi, follow me. The probability proof is not done. This is not done. But did you understand where these are connected together? Yeah. Think about the probability proof. Suryanshi, did you understand? I don't know if others are here over here. Make sure you go back home. So do this problem. Okay, I'm just giving you the problem. I will give you in the WhatsApp group also. This is the idea. Xn plus 1 is equal to Z1 plus Z2 dot Z of Xn. Okay. Xn has PGF Gn of X. Z has PGF G of X, or maybe H of X. Okay. Prove that, this is really important, prove that the following, that this Xn plus 1 is actual PGF, this Gn plus 1 of X is actually equal to Gn of H of X. Sorry. Yeah, which is equal to H of Gn of X. You prove this, guys. It's very easy using conditional probability. Just expand it, guys. Just expand it. Okay. So I will just take a screenshot and give this in the WhatsApp group. Prove it, guys. It's a very easy problem. I will share the solution soon. Okay. Okay, so let's end it, guys. I have another class now. So it was really nice talking to you. The proof is really interesting. The proof is really interesting. Polash, I hope you understood. Polash, I hope you understood. Yeah, Priyansh. All the people out here, any doubts till now, till this point of time? Suryanshi, Polomi, Tanvi, Polash. Clear? Priyansh. Everything clear? Okay. Perfect. So do this problem, guys. It's a very easy problem, not a very hard problem. This is a very interesting problem, guys. This is called, this is called compound processes. Compound processes. It's called random sum. The sum is random. It's hard for you at this age of learning, but if you can do this, I am sure your probability basic is really, really good. Okay, the conditional probability basic is really, really good. I will share the solution in the group. That's not at all a hard thing. Okay, I will just share the solution now. I will take a picture But do this problem, guys. Okay, all the best. See you in the next video.